We're going to continue our conic section study by discussing parabolas. And parabolas are our second conic. We've discussed circle, which is what you get when you cut a cone straight across. And a parabola is what you're going to get when you don't cut the cone straight across, but you're going to cut it straight down. We have graphed parabolas before. This time we're going to be talking about it in the context of conics. So let's talk about what is a parabola. Let's go with this definition. The definition of parabola is the set of all points equidistant from a fixed line, which we call a directrix. And you do have to know that word, and a fixed point. Which we call the focus. Now I'm going to put on this graph the different components of a parabola, and some of these are familiar because we've learned them before, and some of these are not familiar because it's new to you. So we are going to start with just putting a parabola on this graph, and then we're going to put these pieces on. And let's blow that up a little bit. Actually, let's start with the definition. Let's do a fixed line and a fixed point. So I'm going to put a line down here, and this is going to be the directrix. And I need to put a point, and I'll put it about right here. And this will be the focus. Now what you need to be aware of is that neither one of these is actually on our parabola. So if the points are a fixed distance between these two, are equidistant, the vertex for our parabola is going to lie right in the middle, right here. So I'm going to label that V. And then I'm going to draw my parabola so that the points on my parabola are the same distance away from the focus as it is from the directrix. Now if I moved the focus around, if I moved it up like that, then it would spread the graph out. If I moved it closer in, then it would make it a little skinnier, because what you're doing is changing the distance between the vertex and the focus. Okay, so now let's label some of these things with coordinates. Let's this vertex, you remember all the measures, the centers, we use HK, and so we're going to use HK with this. So my vertex is HK. Now to be able to find the vertex, the focus and the directrix from the vertex, we need to know that these are an equal distance. These are equal right here. And so we're going to let P equal that distance. So I'm going to write this up here. Let P equal distance from vertex to focus, and it's also the distance to the directrix. Now to find the coordinate for the focus, we're going to count up p units. So if my vertex is hk, if you see that my focus is going to have the same x-coordinate, but what am I doing from k? I'm counting up p units, so k plus p. And the directrix is a horizontal line going across the y-axis, so my directrix is going to be a y is equal to something. Remember, we're starting at hk and we're counting down p units, so k minus p. Okay, let's talk about, also, we do have an axis of symmetry, and our axis of symmetry is a vertical line which goes through the vertex. So my axis of symmetry goes through the vertex at h. Okay, so parabolas don't just face up and down, they also face left and right. So what I have here for you is we're going to do a side-by-side comparison of the two different types of graphs. And they change a little bit depending on which direction they're pointing. Okay, so let's do the parabola that is oriented vertically, which means it points up and down. So the equation here is y minus k equals a times x minus h squared. That will be a point up and down, and it has a vertex at hk. Now this variable a right here, that is the coefficient that lets us know whether this opens up or opens down. And so we also need to know how it relates to p. And you need to know this as well. A is going to be equal to 1 over 4p. That's how these two relate. Now the focus for this one is going to keep the x-coordinate, and you are going to add p. Now sometimes p is negative, and that means you'll move down instead of move up. Your directrix is a horizontal line, so it's y is equal to, and it's going to be k minus p. And your axis of symmetry is x is equal to h. Now, if A is positive, it opens up. If A is negative, it opens down. So I'm going to sketch one real quick for you. So we would sketch our parabola. And where is the focus going to be? The focus is always on the inside of the parabola. It's always going to be here, inside the cup. And the directrix is an equal distance away from the vertex on the other side. So it's going to be somewhere around here. So here's your directrix. Here's your focus. Here's your vertex. And your axis of symmetry will be here. So it's a good idea on your parabola if you will label everything. Now let's talk about parabolas that go the other direction. And instead of squaring the x term, we're going to square the y term, and that changes our orientation. So here we'll have x minus h equals a times y minus k squared. And this is the same for both of them. The vertex is also the same. The vertex will still be hk. So I want to start with the picture here. Let's make this one face left. And the focus goes in the cup So it's going to go about right here, which means your directrix is going to be on the other side. But instead of, with your vertex, changing the K value, because now you're not moving up and down for your focus and vertex, you're moving left and right, it's the H that's going to change here. And see now your directrix, that is a vertical line instead of horizontal. So let's fill in the rest of this information. So your focus this time, you're going to add to your x-coordinate for your vertex. Your directrix is going to be a vertical line. And your axis of symmetry will be a horizontal line through your vertex. And for this case, if A is greater than 0, you're going to open right. If A is less than 0, you're going to open left. Okay, so let's practice one. Let's take a look at some things here. My y is being squared. That means it's a left or right orientation. This is negative, so it's always a good idea to kind of go, it's going to look like that. Okay, so it's going to open. Now your A, let's go ahead and identify. A is going to be equal to 1 over 4p. A is negative 1/4. And so we're just going to solve for p, and it looks like cross multiply and simplify p is going to be negative 1. That's going to be the distance from the vertex to the focus. So focus, directrix, axis of symmetry. All right, so for your vertex, then make a list of these things. There's nothing subtracted from x and nothing subtracted from y, so your vertex is 0, 0. And let's orient this. So if my parabola opens left, my focus is going to be in the cup, my directrix is going to be back here by 1. So let's put some axes on this. And let's go this way. And since it's opening left, I'm going to put my y-axis a little more towards the right. Label your axes, because there's going to be a lot going on this graph. So our vertex is at the origin, and our focus is going to be, and I like to just go ahead and graph them, is going to be towards the left. And so just by looking at the graph, I can see that my focus is at 0. No, it's not. My focus is at negative 1, 0. Now my directrix is going to be 1 the other direction. And so my directrix is a vertical line, and it is at positive 1. All right, so we're starting to put these pieces together. I want to label this. Here's my focus, here's my directrix. My axis of symmetry is going to go the opposite direction from my directrix, always does. And my axis of symmetry is a horizontal line going through the origin. Now, what I need to do here is, it's time to pick some points. But what we usually do are pick points for values for x. This time, we're going to pick values for y, right here. So we're going to kind of think a little bit opposite and pick values for y. So make your T-chart. Put your vertex in the middle. And this time we're going to plug in for y. and solve for x. So I want to pick some values that will work nicely with the 4, so it will divide. So I'm going to pick -2 and -4 and +2 and +4. And when I substitute those in, when I substitute in -2, that gives me -1/4 times a +4, so that gives me a -1. And symmetry applies here, but this time we're going to be symmetric on the x side. And so this is going to give us the same thing. And I'm going to plug in our -4, so that gives us 16, and that gives me a -4 like that. Okay, so let's plot the points. So we've got -1, -2, that goes down here, and -4, -4, that goes down here. And then we have -1, 2, and -4, +4. And then we're going to connect these in as, oh, I think I missed some points. Let's change that. So 1, 2, 3, 4. There we go. That looks better. And we're going to connect these smooth curve. And we've now got our parabola graph. A lot of steps, but it's really logical. So let's try another one. Okay, well the first thing that I'm going to do with 2y equals x squared is I'm going to put that in standard form and say y is equal to 1/2 x squared. And to find the focus directrix, I have to find the value p. So I remember that a is equal to 1/4p. My a is 1/2. And when I cross multiply this and solve, my p is also 1/2. Now, and that's the distance that I'm going to be away from the vertex, and the focus and the directrix are away from the vertex. So I also want to take a look at my original equation. This is positive, so it's either going to face up or right, and it's the exit squared. So this is an up. Because of that, I'm going to put my x-axis pretty low. And this is going to be centered at the origin, so I'm going to put my y-axis right there, label them. And looking at this, my vertex is going to be 0, 0. I know that because there's nothing subtracted. So I'm going to go ahead and put my vertex on here. Now, my focus, remember, is going to be in the cup. Directrix is going to be down there. So let's move up 1/2, and I'm going to make each block equal to 1/2. So I'm going to put these lines here so that I don't forget. Okay. Okay, now let's identify our focus. The focus is going to go up 1/2. So it's going to be right there. So the coordinates for that is 0, 1/2. And my directrix is going to go down 1/2. I'm going to abbreviate. And it is a horizontal line, y equals -1/2. So if you put them on the graph, it makes them easier to find. And then the axis of symmetry goes through the vertex. It's perpendicular to the directrix. And all this stuff, what it does is that it gives our parabola shape. And this is x is equal to 0. Okay, so I want to make my t-chart. This time we're going to substitute in for x, substitute for whatever is being squared, and put my vertex in the middle. And I want to do values of x that will work with the 1/2. So I'll do -2, +2, -4, +4. And the way I've got my graph set up, we're actually going to go off the graph, but that's okay. So if I put -2 into my graph and I square that, this gives me a 2 on both sides. And then that gives me 8 on both sides. And I'm definitely going to go off my graph, but that's okay. We'll pretend I'm on it. And so we're going to graph, so -2, 2, +2, oh, I missed again. Let's change that. There we go. And then +2, 2. And then we have 1, 2, 3. Okay, well, we're going to completely go off, so I'm just going to not put those on this time. But it makes kind of a spread out graph. And that is our parabola. Now, so far, we've only been graphing things that have had a vertex at the origin. But if you look at example 3, we need to put that into standard form. So we're going to have to complete the square of y. And since y is squared, we know this is either going to open left or right. So we're going to move everything that is not a y term to the other side so we can complete the square. And that makes a +4. And when we factor this, we get y minus 2 squared equals 2x plus 1. And we need to get the a term over, so I'm going to divide by 1/2 to get my a over. So identifying my pieces, I've got a vertex at -1/2, +2. My a is positive, so this one is going to open right. So I think I want to put my my y-axis here. And put my x-axis here. A little crooked, but that's okay. Okay, now my a is 1/2. And a is equal to 1/4p. So I've got 1/2 equals 1/4p. So that means p is also 1/2, like the last one. But this time we're opening left and right, so my focus is here, right there. My directrix is there. So let's put our vertex on, and I'm going to zoom in just a little bit. So -1/2, +2, right there. And so since my p is 1/2, I'm going to go in right there. My directrix is going to be on the other side. Let's start filling in our information. So focus moved to the right, so that means my coordinate is now 0, and it's still up at 2. My directrix is a vertical line, so it is an x is equal to, and it's -1. And my axis of symmetry goes through the vertex, perpendicular to the directrix, and it is a horizontal line at 2. Okay, so we've got all the hard part done, and we'll make ourselves a little chart. Put your vertex in the middle. And what I would actually do for solving is I would subtract the 1/2 over for our equation right here, move it over here for solving this. But after you get everything plotted, your graph will look something like this. And you're going to find the 4 points for your graphing. Okay, now the last thing we're going to do is we're going to write an equation of a parabola with vertex at 3, -1. So that means this is h, this is k. And the focus, look, the x-coordinates are the same, so that's also h. And that 2 means that we're going to add some value to the y value. And so why don't we do this? So let's put it on the graph. Let's sketch it a little bit. So I'm going to put my vertex at, and this is really just a sketch, 3, -1, and my focus is going to be at 3, 2. Okay, well, let's put an axis on here. There we go. And look at the graph. How far up did you go? You went up 3 points. So P is 3. And so we're going to need a value for A, and A is equal to 1/4P. So A is 1/12. So that's my coefficient. And since my focus is right here, my graph will look like that. My directrix is going to be down 3, so 1, 2, 3. Right down here is my directrix. I didn't really ask for that information. So this is an up-down facing parabola, which means you're going to use this equation. Y minus k equals A times x minus h squared. Well, we were given x and h and x, and we just found a, so all we have to do is plug it in. So y plus 1 equals 1/12 x minus h is 3 squared. And that is the equation of your parabola.